We're asked to solve the rational inequality, express the solution using inequalities and interval notation. We'll also graph the solution on the number line. We have x divided by the quantity x plus 4 is less than or equal to 0. To solve a rational inequality, the first step is to factor the numerator and denominator, which in our case has already been done. Step 2, we determine the zeros of the numerator and denominator. These are the values of x that make the numerator and denominator equal to 0. Looking at the rational expression on the left, the 0 of the numerator is just x equals 0. The 0 of the denominator is the value of x where x plus 4 is equal to 0. Solving for x, we have x equals negative 4. Now that we have the zeros, step 3, we plot the zeros on the number line. Zeros of the denominator are always open points because that is where we have division by 0, which is undefined. The open point excludes that value as a possible solution. And the zeros of the numerator can be open or closed points based upon the original inequality. Because our inequality is less than or equal to, because of the equal part, we make a closed point at the 0 of the numerator. Because negative 4 is a 0 of the denominator, we make an open point on the number line at x equals negative 4. And then because x equals 0 is a 0 of the numerator, and the inequality symbol is less than or equal to, we make a closed point at x equals 0. When x equals 0, the rational expression on the left is equal to 0, and 0 less than or equal to 0 is true, which is why we have a closed point at x equals 0, indicating 0 is a solution to the inequality. Notice these 2 points divide the number line into 3 subintervals, one on the left, one in the middle, and one on the right. Now we need to pick a test value in each subinterval and then see if it satisfies the inequality. If the test value is true, the entire interval is true and part of the solution. If the test value is false, the entire interval is false and not part of the solution. Let's go ahead and select our test values. On the left, let's use x equals negative 5. In the middle, let's use x equals negative 1. On the right, let's use x equals positive 1. So let's go ahead and test x equals negative 5. Notice when x equals negative 5, the numerator is negative 5. The denominator is negative 5 plus 4 or negative 1. This simplifies to positive 5. Positive 5 less than or equal to 0 is false. 5 is not less than or equal to 0. This indicates the interval x less than negative 4 is false, and we do not shade or graph the interval. And now let's test x equals negative 1. When x is negative 1, the numerator is negative 1. The denominator is negative 1 plus 4, which is positive 3. Negative 1/3 less than or equal to 0 is true. Any negative number is going to be less than or equal to 0. So because the test value of x equals negative 1 is true, and the entire interval from negative 4 to 0, not including negative 4 and including 0 is true, let's go ahead and graph the interval. And now we test x equals 1. When x is equal to 1, we have 1 divided by 5. 1 divided by 5 less than or equal to 0 is false. Any positive value is not less than or equal to 0. This indicates the entire interval where x is greater than 0 is false. The only solution is the interval from negative 4 to 0, not including negative 4 and including 0. So now that we have the graph of the solution, let's state the solution using a compound inequality as well as interval notation. Using a compound inequality, we can say that x is greater than negative 4 and less than or equal to 0. Or using interval notation, we have the interval from negative 4 to 0. The interval is open or does not include negative 4. We use a parenthesis to the left of negative 4. The interval is closed on 0 or includes 0. We use a square bracket to the right of 0. So now we have the solution as an inequality using interval notation, as well as the graph of the solution. I hope you found this helpful.